Here is the second sample free response question that they had on the College Board YouTube channel. So this is the statistics one. They did this about almost a week and a half ago or so, and this is part of their practice time test. And if you haven't seen the first video on the first free response question, I suggest you go and watch that. But here's the second one. Remember, the second question is 15 minutes. Okay, so it's a bit of a shorter question, but I'm gonna try to do it by typing, just to help you explain how I would type it out, because I think they've geared the questions to be more friendly to typing. Okay, so let's take a look at this. A park ranger at a large national park wants to estimate the mean diameter of all the aspen trees in the park. The park ranger believes that due to environmental changes, the aspen trees are not growing as large as they were in 1975. Data collected in 1970. Okay, so keep in mind the things that thing you want to key up is like they want to estimate the mean diameter, and they believe that he suspects that they're growing not as large, that they're like not as big as they used to be. Okay. Data collected in 1975 indicate the distribution of the diameter of aspen trees for this park was approximately normal, with mean of 8 inches and standard deviation 2.5 inches. Find the approximate probability that a randomly selected aspen tree in this park in 1975 would have a diameter less than 5.5 inches. So this is a straight up normal distribution calculation. And I honestly would draw a picture for this. So here I'm not going to type the answer because I feel like I would really want a picture to illustrate my line of thinking. Okay, so what is the distribution in 1975? I always draw... So if I were to answer part A, okay, so we're going to do part A right here. I always draw a normal distribution curve, okay? And the mean is the center line here. Sorry, that's a horrible line. The center line is 8, and the standard deviation was 2.5. And they want the probability that a randomly selected aspen tree in the park would have a diameter less than 5.5. That means you go on the x-axis, or the z-axis technically, and go to 5.5. We'll just put it about there. It doesn't have to be the scale, it's just to illustrate. And I want the probability that it is less than 5.5. So I would calculate this area here, all right? Now there's two ways to calculate this area. The most common way to do it with a graphing calculator is use a graphing calculator. You can also use a table. But I would prefer to say like, okay, I'm going to use Normalcdf. And the way Normalcdf works is it exactly is designed for this exact process. It is designed so that, double calculators on there. I forgot that like my OBS has it already on the screen. So what I'm going to do is I'm going to do Normalcdf. So what am I going to do? I'm going to say distribution, Normalcdf. Normalcdf translates the z values on the x-axis into area. It helps you calculate the area, and the area is the probability. So what's the lower? The lower is the leftmost bound, and I want to go all the way to negative infinity. So negative 1e99 is good. The upper is 5.5. Mu is the mean, which is 8, and the standard deviation is 2.5. And I might write this out. I might write out exactly what I'm doing on my calculator, and most teachers would understand that. 1e negative 99 upper equals 5.5. Mean is 8, standard deviation is 2.5, and so the probability is equal to, hit enter here, 0.159. Okay, that's part A. Now, the park ranger selects a random sample of 30 aspen trees from the park in 2020 and measures their diameters. A dot plot of the diameter is shown below. Describe the distribution of aspen tree diameters from the sample. Okay, so this I could do with text. Now, I would, at this point, because I've drawn something, you would probably have to handwrite it at this point, because remember, if you haven't taken exams yet that had calculations and stuff, you can either submit a photo or you can submit a document, but you cannot submit both. You could put pictures in a Word document and do a typing and then submit the Word document. I don't know, up to you if you want to get that fancy with it. I might just handwrite it, but I'm going to type it up because my handwriting is a little atrocious. So let's get describe the distribution. Now, there's always 4 characteristics you want to talk about distributions. You want to talk about the shape. You want to talk about any skewness. You want to talk about any outliers, and you want to talk about the center. Those are 4 characteristics you always want to hit up when you're answering the distribution question here. Okay, so describe the distribution of the aspen tree diameters from the sample? Well, the median value, so it's 30, so you can count out where the median value is. So if you want to describe a center for a dot plot, median's probably the easiest because you could calculate the mean, but like, I have to estimate some numbers. The median's easy. So let's count up to number 15 or 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. 15 and 16 are right here. So the center is between 5.5 and 6. Hopefully it makes sense why I did 15. 15 is half of 30, so that's why I was picking that number. The median is between 5.5 and 6. How would I describe the shape of this one? I would say there's two kinds of curves here, two humps. I would call this a bimodal distribution is the technical term, but I would say there's kind of two clusters. It appears to be bimodal. Bimodal is like there's two modes. That's what we mean by bimodal. So there's like a center here. There's like two humps in this curve. You could say like two humps, just to describe the fact that there's two clusters of data. It appears to be bimodal. That's the shape. Any skewness? I would say that because the mean is going to be larger, because there's all these large values to the right of the mean, right? The median's here, but there's just all these large values, more large values to the left than small values to the right than to the left. The distribution is skewed right. Sorry, I keep mixing that up. So whenever there is a more extreme values on one side than the other, you're going to say that direction is the direction of the skewness. It's like where there's sort of a cluster or larger or more extreme values. And you see the values to the left of this median are like closer together. Like they go to about like 2. They're about within 2 away from 6 to 4. But you see all of these values are like beyond 2 away. They're like 8, 9, 10, which is like 2 to 4 away from where the median is. And so those values are more extreme, and that's why it's skewed to the right. The distribution is skewed right, and I would say, in outliers. And there doesn't appear to be any extreme outliers. Okay. So those are the 4 things you just generally want to hit when you're asked about the shape of something. Okay. Assume the conditions for inference have been met. The park ranger uses the sample data to construct a 95% confidence interval for the mean diameter of all aspens in the park in 2020 as 5.6 to 7 inches. Calculate the point estimate in the margin of error. Well, this you can write out, or type out. But basically, remember confidence interval, the formula is it's always your point estimate plus or minus the margin of error. Right, because it's always the center. So how do I calculate the middle? So the point estimate is just the middle of the confidence interval. That's all you really what it comes down to. So C, I would say, the point estimate is the average of 5.6 and 7.0, which is 12.6 divided by 6.3. 6.3 inches. The margin of error is the difference. I could just say it is 7.0 minus 6.3 or 6.3 minus 0.7, 5.6. It doesn't matter. It's just like how much you went up and below to get your endpoints, and that's 0.7 inches. That's it. D. Based on the confidence interval, does the park ranger have convincing evidence that the mean diameter for aspen trees in the park is different than 8 inches as it was in 1975? So, we have convincing evidence because what does the confidence interval tells you? It tells you you're 95% confidence that the mean diameters are between here and here. The population mean is between there. So, I would write that out maybe, just to explain that. The confidence interval. So, the park ranger is 95% confident that the true population mean of that the true mean diameter of all aspen trees in the park in 2020 is between 5.6 and 7.0 inches. That's what the confidence interval means, because it does not contain 8 inches within the interval. We can conclude then basically what we're saying is he's 95% confident that the true mean, that the mean diameter is not 8 inches. Right? Because if we're 95% confident that the true mean lies between 5.6 and 7, that means we're 95% confident it doesn't contain 8, right? 8 is not within that interval. So because of that, we are confident. We have enough evidence to suggest that the mean diameter of the aspen trees in the park is different than 8 inches. Okay? That's pretty much all it comes down to. Like, I probably put in more words than were necessary, but I kind of want to, I would like err on the side of just being very clear as to like why I think something is true like that. Okay. Aspen trees tend to be smaller in the highlands of the park because they are subject to strong winds. While the number of aspen trees in the highlands of the park is about the same as the number of aspen trees in the lowlands of the park ranger is concerned that 24 out of the 30 trees in the random sample came from the highlands. So highland trees tend to be smaller, right? Propose a sampling method to address this concern. Describe the benefit of using that sampling method. Okay, so if you have two categories, here's the problem: is even though he randomly selected from the group, just by his randomness, he happened to grab too many from the highlands group. Okay, and that is a weakness of it. If you think there's two groups and that they would behave differently, then you may want to separate those and sample from each group, and we call that a stratified sample. He could use a stratified sampling method instead. He could randomly select 15 trees from the highlands and 15 trees from the lowlands of the park, so that the resulting data would not be biased towards highlands or lowlands. Okay. I think that was it. That's all you gotta say. I gotta propose a sampling method to address this concern and describe the benefit of using that sampling method. So you're just gonna you're gonna stratify. You're gonna separate into two groups, and you're gonna randomly sample from each group. But you're gonna ensure that this guarantees that you have 15, that you're not like biased by having too many of one in the other. All right, and that's it for that 15-minute question.